is the pine beetle killing more than just trees? My name is Annette, and today I want to answer that question. I want to talk to you about the impact the pine beetle has beyond the killing of trees, specifically its destructive effect on riverbanks and their ecosystems. First of all, who is the pine beetle? The mountain pine beetle, or the Dendroctonus ponderosa, is a beetle that is native to western North America from northern Mexico to northern BC. This beetle attacks and essentially kills trees through mass colonization. Trees can defend themselves against the pine beetle by emitting a toxin called resin. This works in controlling the beetles when the population is low. The trees in British Columbia have previously relied on cold winters to kill the pine beetle, seeing as, during cold temperatures, the beetle larva dies. However, several mild winters and warm, dry summers, combined with many suitable pine tree hosts, have led to the epidemic that occurred in the 90s and 2000s. The epidemic affected large portions of BC and Alberta, as you can see on this map. 18 million hectares of forests were impacted and resulted in the loss of 723 million cubic meters of pine volume by 2012. That's enough wood to build 80,000 single-family homes. The damage that the pine beetle has done to the forests is immense, as you can see from the red trees in the photo. The epidemic is being dealt with by clear-cutting affected areas of forest. This significantly affects local ecosystems, especially near the river and on riverbanks. Trees on riverbanks are important to ecosystems because the trees regulate rainfall by intercepting it and absorbing part of the water through their roots. This protects the riverbank and controls water runoff, therefore also protecting the local ecosystem. The riverbank needs this protection because it controls erosion and runoff, protects the quality of the water through natural filtration systems, moderates water temperature, provides shade and nutrition for aquatic life, and a habitat for wildlife. It also ensures a long and short-term supply of large wood debris. None of this is possible when the riverbank is not protected by trees on its sides. Large wood debris is a particularly important aspect. It's made up of logs, sticks, and branches and other wood that falls into the river, but from surrounding trees. This debris can influence water flow, shape the stream channel, protect aquatic creatures from predators and from the current. But pine tree-infested wood can't be artificially planted because it will spread the epidemic. In order to assess and deal with the potential impact of the pine beetle on rivers and aquatic ecosystems, the Bowron River Watershed Project was launched. This project looked at an area near Prince George, BC that had been impacted by the spruce beetle outbreak in 1975. Upper and lower areas of the river were evaluated. The lower site was chosen to show cumulative effects and had not undergone such severe clear-cutting. The upper site was a smaller stream that was selected to identify localized harvesting effects and was typically clear-cut right to stream edge. The study measured disturbances in riverbed and bank, how well the river connected to other streams, to reflect whether current flow was normal, fish and invertebrate diversity, and frequency of storms. The study also observed wood debris supply, disturbed or bare ground, shade, effects of water runoff on the bank, how well the plants were adapting, whether local plants returned to the area, and the number of plant species. This study is an excellent predictor of long-term effects of the pine beetle devastation, but the findings are alarming. You can see the results in front of you. The heavily harvested upper basin is nowhere near recovery, and only 16% of the lower river basin functions properly. 20 years later, and the Bowron River watershed has not fully recovered from the large-scale salvage harvesting activities in the 1970s. Problems observed include fish passage barriers, limited vegetation regrowth, low watershed function, low fishery productivity, problems and inadequate regrowth to provide future large wood debris and fill those requirements. These results are alarming and predict bad things for British Columbia's future and the future of our aquatic ecosystems. So the results are in, but what's being done? Further research and a best practice compilation for infected forest clear-cutting to minimize its effect has been proposed, but this won't solve the issues of lack of tree cover and disruption to local ecosystems. What should be done? We need to replant trees beside riverbanks where they're most needed. We need to do further research into fixing the problem. We need to test these newly developed best practice theories and, of course, continued research. Please remember that getting rid of the pine beetle gets rid of the infection, but not the large-scale problem. If you have any questions about any resources used, please look at the information provided or post questions in the comments. I appreciate your attention. Thank you very much.